Hello folks, welcome to what's going to be a decidedly boring video. We are going to be talking through the latest version 2.04 VCU firmware. Before, however, we get into that, I would just like to remind you that my videos are also available on Vimeo, free of various BS. So I'll put a link in the description to my Vimeo channel as well. So enough about that. What we're going to be talking to you about today is not going to be EPROMs. What we're going to be talking to you about today is going to be the latest firmware release for our Zombieverter VCU, and it's got some new features in there. So for about the last week, a little bit over a week now, I've been testing out some of this stuff. So we're gonna walk you through first of all the release notes here. Then we will show you the web interface with some of the new additions here, and finally we'll just show you a few little demonstration videos. So let's get straight into it. I'm going to assume everyone's at this point familiar with what the Zombieverter is and how to do things like software updates and view the web interface and stuff like that. If you are not familiar with that, I would strongly suggest watching some of the earlier videos in this series. So let's get straight in. So over on GitHub here under releases, we have our version 2.04 release, and the binaries and source are available here as well. So I just run through the release notes quickly here so that we can kind of expand a little bit on them, because you have to be reasonably succinct with them here. So bug fix, there was a particularly pernicious bug in the IO matrix. Now the IO matrix is a reasonably recent addition to the firmware that allows the input and output pins, the function of them, to be changed from the web interface. So they're not hard coded, so like one pin isn't necessarily dedicated to one function. And that's a great thing, but unfortunately there was a bug in there, and what it would do was the HV request function, which is used by external chargers to request the HV to be switched on, was not functioning. And there's another kind of a HV request, but it's designed for CHAdeMO fast charging, and that was actually swapped with the AC charging HV request, and the AC charging HV request was not functioning at all because it was out of bounds of the array that was defining these pins. So it took quite a bit of finding for my brilliant software skills to detect that, obviously, but got that and fixed it. Next up there, we've added a under the vehicles, we've added BMW E31. So for all you people who want to EV your Panzer, you'll have a reasonably good integration experience there. Now there is one little other thing there that's quite nice, in that we're bringing the ability to run analog dashes in here. So things like pulse driven tachometers, pulse driven speedometers, resistance driven temperature fuel gauges and things like that. So that's the beginning of that. So it's not just for converting Panzers. A lot of this stuff can be copied over, like it'll be for the red arrow, the E36, and then you know, I kind of like to think that when the skeleton or the framework or whatever you want to call it is there, folks can kind of then add their own vehicle classes to that. So OBD2, this was particularly exciting, was an addition from another user. I apologize, I've forgotten your name, but it's in the GitHub history there, so thank you very much for that. So what that does is it basically lets you use Torque Pro to have a dash and to display info from the VCU using one of these ELM 327 things. Now, unfortunately for me, I of course went and got one of these AliExpress, you know, $1 or whatever it is, OBD dongle thing here, and I spent better part of a day trying to make it work, but it absolutely just did not want to work. At one point I actually did get it to connect to Torque, and I was able to look at the CAN and see the CAN being exchanged, but I just could not get Torque to actually recognize the VCU. Now, other people though with more, I would say, better OBD Bluetooth things have actually confirmed that this works, so that's really good. I've ordered some less cheap ones, so I'm just hoping that it's not just less cheap but the same guts, so fingers crossed. I've got a reasonable little test rig here now, so I'll be able to try a few different things, and once I figure out what works and what doesn't here, I'll swing back to you and let you know. But it's a really nice thing, just a shame that I can't demonstrate it here for you today. So moving on then to the I/O matrix. The VCU has since the beginning had two analog inputs, and they've never really been used for anything. Now, Jamie Jones, who is doing a BMW E90 Touring build, has added those in, made a little analog I/O matrix, and there's now functionality. There's two functions that you can use these pins for. One of them is to monitor a vacuum sensor to running a brake pump. It's like a brake vacuum pump. And the second is to monitor the PP signal from a charging port to bring on charging mode. Now, personally, I don't use the VCU to run a vacuum pump. I do the kind of old school thing where I literally just trigger the vacuum pump via a relay from a brake light switch, but a lot of folks seem to like having them driven by actual vacuum in the reservoir, so that's a nice feature to have there. Slightly more thing that I can show you, and we have a little clip up in the workshop to demonstrate this, is the addition of a gear shifter class. So what that means is that our VCU normally just uses two 12-volt signals to decide whether you're going to drive your motor or car or whatever forward or reverse. So pull one of them high, you go forward. Pull the second one high, you go reverse. And that still works, that's still functioning. But I've added in the facility for these kind of, oh my god, what a mess of wires, these kind of CAN based shifters. So you can, this is a BMW F30 shifter, so it literally just has power ground, 12 volts ground and CAN. We'll show you this on the web interface working there in a few minutes. So at the minute there's the F30 shifter and just the normal 12 volt signals, but there is a facility now to add in more of these CAN based shifters, so it might be a nice touch. On the subject of the BMW F30 shifter, I did not do the reverse engineering work on this. I ripped off other people's work. One of the people that's done the most work on this is a guy called Project Gus, and he's got a brilliant website here, which unfortunately when I went to look at it here to pull it up for you guys here this morning was actually down, so hopefully that comes back soon. I will put a link in the description of this video for this, because this is a real this is a real kind of a doing it the hard way of reverse engineering. So there was no CAN logs available and so on, so this guy had to really get stuck into this the hard way. So if you want to see what it takes to reverse engineer, you know, an EV, or you know, even a non-EV V component, this is a real education here. So I'd highly recommend having a look. I've just pulled it up on the Wayback Machine here just to have a look at it, but hopefully the normal website comes back soon. Next up, we have added DCDC Converter control to our VCU. Now at the minute, the only one that I have in there is the Gen 2 Tesla, but I guess the framework is there now, so it won't be as hard to add other CAN controlled DCDC converters. The open inverter CAN class has been updated to the new way of controlling inverters via CAN. Now what that means is there was a little bit of I don't know what the right word is, a little bit of controversy, I guess, there a couple months ago, when it was kind of discovered that you could get into some kind of potential problematic situations when controlling the open inverter controlled inverter drivetrain kind of thing via CAN. So Johannes and some other folks there have modified that now, and that's working well. I've got that working in the Panzer now. So we've got updated that in the VCU and in the Tesla drive unit in the Panzer, so that's working away happy now. That's it for the release notes. Obviously this video, once it goes public, I'll put it up here as well in the release notes. So again, I'm assuming you know how to just download these and put them into your VCU. So again, if you don't, just have a look at some of the previous videos in the series. So let's have a look here at our parameters and we'll get started. A lot of things are the same here, so I'll skip over things that are broadly the same as have been in previous episodes. So our inverter list, vehicle list, whether it's a manual or an automatic, excuse me, and then you can decide which CAN bus your inverter, shunt, limb, charger, BMS, and so on are connected to. Now there's a few additions here. The OBD CAN, so you can decide which CAN bus you have your not so cheap ELM 327 connected to. CAN map CAN is another addition here, and this lets you decide which CAN bus, if you were to come down into the spot values. So if you set up any of these via the CAN map here, for transmission and reception, which of the main CAN buses that you can choose to use. DCDC Converter CAN, you know, obvious enough, it's whichever CAN bus that the DCDC Converter is connected to. And gear lever lets you decide what kind of gear lever that you want to use. Now the default is none, and what that means is if you have none selected here, it just means that you're using the default 12 volt signals. But then the only other option as of this release that we have is the BMW F30 shifter here. But I would imagine that we'll have other CAN based shifters added in here. You know, the only thing is that as other folks add these in, if I don't actually have it, I won't be able to verify that. So I will be relying on you folks to kind of test this stuff for me. before we get into adding them to official release firmware. So, all right, things here in Throttle are the same. There's nothing really changed in this area, but I'll just quickly run through it because I did hear that there was some confusion about how to configure the throttle and so on here. So basically, I would recommend to you that you always use dual channel throttle pedal. I'm not going to get into the whys and the wherefores, folks. That's a thing you can kind of look up for yourselves. And so you've got two channels. You've got pot and you've got pot 2. And you've got the raw digital values here. If you come down to spot values and we go down to pot, you'll see what they currently are here. So see at the minute pot is at, so this is channel 1, this is channel 2. Pot's at 223 and pot 2 is at 431 with the throttle. It's just sitting up on the monitor there. It's completely released. So what we want to do then, so if we take 223 from channel 2 here, we want to make sure that our value for pot min is below that. Okay, so it's pretty straightforward. Same with the second channel, and then for the maximum value you want to make sure that this value is a little bit less so that you always get to full throttle, right? So just to clarify that, regen is still not implemented in this release, but everything else here kind of works away as it should. So you have your throttle ramp, rev limiter, and so on. UDC min is obviously the minimum voltage that we want to operate at, the HV. UDC lim is a little bit, I always find UDC lim a little bit confusing for me. But what that is, it's just the maximum HV voltage that you want to work at. Throttle max, throttle min's the same, quite obvious. Throttle dead zone, that's just how much of the throttle that you press before you actually request torque. Gearbox controls for our Lexus, it's the same. Cruise contactor control, again, is the same here. UDCSW is your pre-charge threshold. Cantry speed, again, this is for Cantry is used at the minute for either CHAdeMO fast charging. So if you have CHAdeMO selected here, you want to have K500. I use it. I use Cantry for CHAdeMO in 2 cars, and I use it for controlling Vauxhall Ampere heater, which is single wire can. So that's where the 33.3 option comes in there. Charger modes, same, not really changed here. I'm not going to waste time going through this. I have explained this in the past, so if you want, a bit more on this, then yeah, do have a look at some of the other videos where I've explained this. DCDC Converter is a new one here, and basically options are at the minute just no DCDC, so you could use external control for it if you do have one, or the Tesla Gen 2, and you can set the DC set point here, the 12 volt voltage, system voltage kind of thing. And then if we shoot down the spot values right around the end here, you'll see U12 volts, I12 volts here, and that'll be your DC-DC voltage, and 12 volt DC-DC voltage and 12 volt current here. So let's see, yeah, that's our DC-DC. The battery management system interface here, not sure if I've gone through this before. It's pretty straightforward. At the minute it's a very basic interface, and that's the way that I like it. I have a very I would say non-popular view about battery management systems, but we're certainly not going to get into that. It's like discussing religion and politics all heaped into one. But at the minute, what this will do is it lets us set some limits during the charging. So you can set a min and a max voltage and temperatures and so forth, that the VCU will then terminate charging if we exceed any of those. Now the off, it just means that it's disabled and there's no limits set. And then you can choose which of these that you want to use. The Simp BMS one is probably going to be the most common for folks, because Tom uses a, a very standard can. I think it's the Victron can implementation on that, and you will actually see me using that in the Panzer soon with our BMW hybrid battery pack. So it'll be more about that when the time comes. Heater control at the minute, the only one that works in this release is the Ampera, but I am working on the Lin controlled VW version, which I have in the Panzer, and that'll be in version 2.05, which will hopefully be released soon. In fact, as soon as I get this heater module working, I'll probably do a I'll do a 2.05 release to get that available for folks. You'll see here on the Open Inverter wiki, there's this is the heater that we used in the Panzer. It's Lin controlled, so I'm implementing that now in our VCU. Real-time clock module I've explained in the past. Now the gpios and how they work, I will do a little bit of a run through on this because it has changed significantly, and again, thanks to folks that have contributed this. I didn't do any of this at all. So when you first load up, the default functions for these pins here will always be what they were when I had them as fixed pins. So if you touch nothing here, basically you can look at the pin out diagram, and the pins that are assigned to those functions will automatically be assigned to these functions here. So in this case, out 1 coolant pump, out 2 negative contactor, and out 3 heater enable. But if you don't want to do that, then you can simply click on the menu, and you get a menu here of all the functions that you can assign to that pin. Now, there is one thing to be very much aware of here. The hardware in the VCU has got obviously input pins and it's got output pins. Now, that's hardware defined, so you cannot change. You cannot, for example, have an input pin provide outputs and vice versa. And that's one little bit, I wouldn't quite call it a bug, but it's just something to watch for here, because if we take out 1 here for example, obviously we can assign any outputs to it, but on the menu as well, there's things like heat request, HV request, DCD or DC fast charging request, and these are inputs, but they won't work if we assign those to an output pin and vice versa. So that is something that we do need to clean up, so that output pins only can be assigned outputs and input pins can only be assigned inputs. So just do be aware of that when using the IO matrix. So some folks ask me about the capabilities of the PWM pins, and in the initial design, when I was doing the hardware design, like, they were obviously designed to be PWM, so driving low level or low power, I should say, signal. So like, I don't know, a fuel gauge or something like that. Now they are assignable as output pins here, and you can indeed use them to drive ground and drive 12 volts, but not to the same power that will be available on the main output pins, which use NCV8402 protected drivers. The PWM pins use basically a MOSFET driver, a low side MOSFET driver, and there is a fuse in there on the VCU board to protect them from, you know, people trying to, I don't know, wind up a window with them or something, right? So be aware that I would say, you know, certainly no more than 500 milliamps. So you can, let's say I use them, for example, in the Panzer. I use them, say, for controlling the alternator warning light on the dash. So that's just a little pygmy lamp, right? And there's no problem with that. You can use them for, you know, providing a 12 volt enable signal, say, into a charger or something like that. So just be aware of that. These are our two inputs, our GP 12 volts and our HV request. And again, thanks to what folks have submitted to me here, you can now choose different inputs on those pins. But again, be aware that if you look at the menu here, it would fool you into thinking, oh, I can, you know, have, for example, HV request here to drive a brake light. Well, no, because it's a hardware input system, so you can't actually do that. Now, our analog pins are now definable, and they can be assigned to monitoring the proximity, the PP signal, on a type 2 charging port, or a brake vacuum sensor. Now, I haven't tested this. I know Jamie Jones has. There's a link to his channel, by the way, in the video here, and I'd recommend you to have a look at that, because he's doing a very good job converting a BMW E90 Touring. So again, I haven't tested this, but he demonstrates this on one of his videos, so I'll leave that to him. ISA shunt control, a little bit of a misnomer. I should probably take the ISA out of it and just have shunt control in here. So you have your ISA init function, and you can then choose whether you want to use the ISA shunt, the BMW S box, or the VW, I think it's called E box, is it, or some other thing. But again, I've demonstrated that in previous videos, so do have a look at that if you wish to use either of those. Now, PWM control. This is quite interesting. Not something I've used for current builds, because, like I said, I've written a class for the E31 that kind of controls gauges and stuff. But this lets you connect timer 3 in the STM32, which is general purpose timer, to any of the three PWM pins here. So for example, if we took PWM function 1 and changed that to PWM timer 3, we could then create a PWM signal out of that pin using these values here. So quite interesting. You can actually do all three of them. You can connect all three of these to timer 3 and then create your own PWM outputs. So that's a really nice function. So I've got the VCU in run mode here, and I'm just going to show you just very quickly here. We'll go to auto refresh on this. You see we're in direction neutral here, which is reflected on our shifter, so we can go into reverse. It should go into reverse, which it does. You can come back to neutral, We can go to drive. I've also changed so that forward is now drive. It doesn't do anything differently, it just does what it does. You can go back to neutral, and you've even got, sorry, there is a little bit of logic in this, so you can't just saw the gear lever back and forth. Tom Debris did the code for this that I ripped off from his GitHub, so you do have to be you do have to hold down one of these buttons or something. I've probably made a mess out of it now, but yeah, so anyhow, that's our gear lever, which I just broke. Oh, I love it. Can only happen on camera to me. Ah, there we go. Okay, now we're in drive. I was pushing too many buttons. I think you have to, yeah, so you can go one, you have to go two back to get into drive. But if you go one click forward, and then you can't just go into reverse, you have to hold this button down. There you go, and then you're in reverse. And you can come out of reverse, I think, with one click, can you? No? No, you have to go 2 clicks to get out of reverse. 2 clicks then to go back to drive. And I think then, oh yeah, there it is. You press P, then it'll go into park for you. Now, I've added a park function here, you know, under directions. It doesn't actually do anything differently than neutral at the minute, but it's just adding that in, so that if we do have, like, I don't know, let's say we were, oh, I don't know, let's say we were controlling 8 HP gearboxes or something in the future, then we'd have the ability to engage park via CAN. So, see, I'm getting a bit of sun on my face. You've got to see my better side here. So anyhow, folks, that is just a very short walkthrough for you here of our 204 firmware for the VCU, and I'll show you just a few little clips now of us running tests. It's currently running in 3 cars, E39, E46 and E31. Okay, so let's have a look at our F30 shifter here. Pretty straightforward, really. There's now a menu option in the VCU that lets you decide what form of gear shifter that you would like to use. The none option basically defaults back to the 2 12-volt inputs that choose forward and reverse. But we've now got a class in there for using CAN-based shifters, such as this guy here, which is our BMW F30 shifter. So this is basically just got 12 volts and CAN, and is talking to our VCU on the bench over there. And currently on its kind of display here, it'll show the current selection that the VCU is in. So it's currently in park. If we press the park button, we go into neutral, and we can then, just like in an F30 or other car that uses this guy, to press the unlock button and then double click forward to go into reverse. Then you can double click back to go into neutral and double click back to go into drive. I don't know why, I haven't quite figured this part out yet, but I annoy it if I put it into the sport section, it just pops back out, so I'm probably sending it the wrong message, but that's not really too much of a concern for this release anyway. So that's drive. You won't be able to see the prop shaft over there, but we can press that, we go in one direction. We can go into neutral, obviously we don't do anything, and then pressing our unlock button, going into reverse,
go into reverse, and then we can go back to neutral. And oh sorry, yeah, then we go back to neutral, go to drive, or we can go to park then from that, and that obviously doesn't allow any torque commands. Now at the minute, this park function, other than like it's basically the same in the VCU as neutral, it just zeroes out all torque requests. So the usefulness of this isn't at the minute. It will be when we're controlling certain gearboxes and drivetrains that have an electronic park facility in them. Alright, so we're going to start things up here. Give ourselves some voltage, a little bit of current to drive our GS300 system here. We're going to switch our ignition on, and we will hit our start button. So right now we have our BMW F30 shifter here, and if I shift it into reverse, got reverse displayed, push our throttle, and you'll see that we turn in reverse, shift back to neutral, press throttle, we get nothing, shift back to drive, and so on. Folks, I was planning to tell you this morning about how I was getting 204 deployed into all of the cars with the assistance of the new GOM here. But the new GOM has, let's just say he's a family man. I don't know if you're going to be able to see this because they're quite small. But up on top of that solar array there is 3 kittens, as one of them is underneath it, and the mother cat is in under the solar panels. They seem to have made a nest here where the, I'll try and walk up here. They seem to have made a nest here where the dead grass is under the panels. So I'm getting absolutely no work done here this morning because I'm just basically standing here watching them playing. They seem to really enjoy the solar panels, probably because there's the first bit of sunshine in, I don't know, weeks now. So as promised, folks, some funny cat videos for you finally after, I don't know, coming up on 15 years. I finally make a funny cat video for you. Oh wow, oh they've gone crazy. So they've been eating me out of house and home here for the last few weeks. They arrived just before Christmas. So yeah, we've got new workforce here. So I'm hoping that these guys will have some better software skills than me anyway. And they've already displayed significant mechanical engineering abilities insofar as where I've in the workshop there of all the parts for the E36 rear subframe that I've to rebuild. They have gotten all of my brake pipe clips out of the bag and have dispersed them all around the shed. How that's supposed to help me with fitting the brake pipes to the subframe and the freshly painted back of the car, I'm not so sure, but maybe I can get them to carry some of those parts out for me. So there it is, folks. The new workforce has arrived, and oh, by the way, yeah, the mother cat has another batch on the brew as well. So yeah, right now, if you will excuse me, cats, we've got 204 now in the land yacht, the goose and the panzer, so I've got to continue testing. make sure there's nothing weird going on here. When I put 204 into the land yacht, I thought I had a serious problem because the ABS light stayed on. But not to worry though, nothing to do with the can or the VCU. Just turns out the yacht has thrown an ABS sensor. So yeah, we got to fix that. So we're testing charging now on 204 in the Goose. The Goose is on charge. The Goose uses the limb as a charge interface, and the well, what's the name of it, Outlander charger. So there's the Goose charging. We're going to monitor this now, make sure we get charge termination correct. Then we'll be doing the same with the land yacht. I won't be doing the same on the Panzer yet, because we still don't have our BMS can bridge type thing worked in there. Had an idea actually, I might try and get one of Dala's 3-port can bridges, would be ideal for that job. So now that, oh boy. Okay, so speaking of the subframe, I see this one has decided to work on the subframe. Hello, you're my subframe helper. You finally came in to help with subframe build. Look at you. Okay, I know the sun is all over, sorry folks. This is my subframe helper. Look in there. There's the father. Are you going to set a better example there, mister? Because the subframe's not going to build itself. Like, look at all those parts that have to go together, and you're not setting a good example for your little son that's hiding in there. So as usual, Muggins will probably end up having to do it. Oh, here's another helper. There's another helper. Are you coming down to help as well? Maybe you can help with the VCU software testing. Anyway, it's actually sunny. I can't believe it. That's why I'm standing out here. Smell mobile. All the doors open, so hopefully we'll be able to disperse the smell somewhat. Right, back to work. No more messing. Oh look, it's another cat. This is why I'm getting nothing done today.
Okay folks, so I do hope you've enjoyed this one, though can't really see how you could, but we did have some funny cats in there for you finally. Okay, so we'll see you in the next episode. Hopefully we'll have a 205 release soon to get some heat going in the Panzer. And yeah, so don't buy cheap OBD dongles because they don't work. So I'll also hopefully have a non-cheap OBD dongle that we can demonstrate the torque dash type thing with our VCU. So as always, links in the description folks. There's some interesting stuff from other people's channels in there that I've got in there for you. Open Inverter Forum, GitHub. As usual, don't support me with Patreon, PayPal, any of that, because then I'm just going to keep doing crappy software and crappy builds and all this. So as you know, it's a mistake. Don't do it. So that's it. I will keep you posted on the firmware. I know it's kind of don't really have a good release schedule, but it's when I get enough new stuff in there, I gotta get it tested and so on. The testing is the thing that the test and the debug are the things that really take a lot of time and a lot of iterations and so on to get right for you. So that's it. Won't keep you any longer. And I've actually got a few designs here that I'm working on, so we might do a little lab update video for you soon, just as a kind of a general look at a few of the coming soon things. So that's it folks, until next time, Happy Bluetooth fixing.